You know, building out a school bus is nothing like building a house on foundations. And today those differences continue as we begin our journey framing our interior walls. First thing we're gonna do is forget this dimensional lumber. Don't go anywhere, because I'm gonna show you methods we've developed over the last 8 years that will save you time, money, get you a higher performing insulation system, straighter walls, and plus, it'll just be easier. Don't go anywhere. My name's Chuck Cassidy. Today is gonna be a good one. One of the ways you know you're at the right age to start making dad jokes is if you're going to the lumber yard at your local Home Depot or wherever and complaining about the quality of 2x4s you're seeing. Welcome to the club. But I'll tell you, they don't make them like they used to. The studs you get these days, well, they're from younger trees. The grain is not as dense, it's not as strong, it's not as straight. There's no way around it. And that makes it especially problematic when we're selecting our wood to frame out our school bus, because the big difference and what we'll be doing is we'll be using screws for everything instead of framing nails. And when we drive these screws through the wood and into the steel, we run the risk, especially as we go through the face of the grain, here and here, if we drive our fasteners in the face and hit that grain just right, we're very likely to split it. If you're putting a lot of screws in the face of this board without pilot drilling first, you're gonna split that sucker. So that's reason number one. Reason number two, like I was saying before, these boards just are not straight. I mean, we can sight down this guy and it's got a nasty twist to it, and that's just not gonna work for us. We want something straight that we can trust, that's gonna be easier to work with, that's not gonna split. And that's where I want you to meet the material we'll be using to frame the bus today. And these are 2-inch wide sections of 3/4 inch ACX plywood. Now you can use more expensive plywood if you want, but I wouldn't use cheaper plywood than ACX. ACX is a designation for a type of plywood denoting that one side is the A side and one side is, well, just not much to look at. But that'll be fine for our purposes because we're not worried about aesthetics. What we want is strength. And this is a pine species type of plywood, just like the wood we would be using to frame a house. But because we can rip it to sections on the table saw, we can control exactly how straight it is. And since it's got a little bit of give in it, that's gonna play to our advantage as we screw it down. We can make sure that it stays nice and straight. Now you're probably thinking to yourself, Chuck, that's not as much wood, it's not gonna be as strong. And you're totally right, which is why we will be doubling this up with another course of this strapping material, which is what we call our framing in the bus. We call it strapping. We'll be doubling up with another course of this so that our finished dimensions will be 1.5 inches thick by 2 inches wide. It's gonna be perfect for what we're doing, and because we have so much structure to tie into, it's gonna be more than strong enough for what we need. Let's head over to the table saw and start ripping some sheets down.
I'm gonna be making a lot of cuts here on the table saw, so I thought I would just go over some of my favorite table saw practices. When I'm doing these big sheets, I like to start with that leading corner up against the fence, and as soon as the blade bites, then I push the rest of it up against the fence and follow through. I also like to rip my full sheets in half before I get into ripping them into 2-inch sections, which I'm about to do here. You'll notice I actually took my gloves off, and that's because when I'm doing finer work on the table saw, I really don't like wearing gloves. I have this huge fear of the tip of a finger on a glove getting sucked into the table saw, so I take them off and I'll take the splinters. There you can see I just flipped the board over, and that was so I could start working from the other factory edge. When I'm doing this type of work, I'm always trying to minimize the additive properties of the errors I make along the way. So if I screw something up, well, if I flip it over halfway, that will kind of reduce the magnifying qualities of that mistake. Here we go on the last cut. You can see it jumped a little bit there, and so I got spooked and decided to use a pusher through on that. Really, when you're doing this kind of work, it's whatever is most comfortable for you.
Now that we've got a nice pile of ripped plywood ready to be installed, let's go ahead and talk about the tools and hardware we're gonna need to complete this task. Now the first thing I want to point out is I've seen tons of folks framing out school buses, even other professional builders on YouTube, who are unaware that this type of screw exists. And let me tell you what this type of screw is. It is a self-drilling wood to metal screw. All right, if you take a look at this, you can see that it's got these little fins on the end, and then it's got a metal drilling point on the tip. What this will do is it will use the paddles on the side of that drill bit to get through the wood, and then when it hits the metal drilling bit will then pilot bore the hole through the steel. As soon as it gets through the steel, it passes through the hole it just drilled, and those ears get ripped off by the hole. Then these fine threads that are spaced for optimum grip along the arbor of the fastener bite into the metal and pull it tight. And these screws are amazing. They have excellent holding power in anything from about 18 gauge on up. I mean, they will break the wood before they will strip out. And I've seen so many people, these other builders, who are using all kinds of crazy screws not meant for this purpose, and they are stuck there, especially with their dimensional lumber, pre-drilling through their 2x4s and then pre-drilling into their steel, sometimes with the wrong steel bit, and then driving in the wrong fastener that's not going to have a countersunk head like that, and it's going to sit flush or sit proud. That's just not what we want to do. We don't have time for that. So we've always used these screws around here because they go in very easy, very fast, and they grip exceptionally well, and they save you the time and the headache of pre-drilling all of your material. We also have those screws in another flavor. So these are great for attaching. These are 1 7/16". They're great for attaching our 3/4 inch material to the wall. If you're going to be attaching, 1.5" thick dimensional lumber, which I don't recommend, but if you're doing it anyways, Tex, which is the brand, and I like Tex the most, they also offer these in a bigger number 12 profile that are 2 3/4 inches long. And this will work for attaching everything up to a little, like just about 2 inches thick to steel. These are great. The length is handy too. If you're deciding to screw down maybe, your subfloor into your floor pan, again, which I don't recommend, but some people do it, these are a great option for that. Now, when it comes time to attach the wood to itself for that second course, I want to get into a little bit of fastener theory here. So here is a standard number 8 1.25" long wood screw. I really only use screws that have the Tex or the Torx head on the back because they just don't strip. And I'm a huge fan of that style. I really don't like Phillips. They strip very easily. So these construction screws are meant for screwing wood to wood, which is exactly what we're doing. However, in order for it to pull tight enough for that flathead to countersink into the wood and leave you see if you look at that there, I wish it would focus, yeah, and leave you with a flat surface on top, those screws, the threads on the screws have to bite really hard enough to compress the wood and force itself into that. And since we're going into our plywood here, that might not happen. The screw might lose bite, strip out, and then that screw's not even doing anything for you. So what is mandatory in this application is using a pilot drill with a countersinking head. If you'll notice, this has a conical tip to it. And when you pre-drill that, when you pilot drill that, it gives you a hole that will line up perfectly with the countersink on the back of your fastener so that it sits flush without having to pull so tight that it might strip out the bore that it's going through. So those are the essentials for doing this job and doing it well. Now I want to get inside the bus and go over the layout. We've already gotten started on here, but I want to get in there and show you what we're doing, why we do it this way, and what the benefits are. A lot of folks I see, they'll run their framing on top of the hat channels. There's a concept in building science called thermal bridging, and these steel, we'll call them studs for our purposes, are metal, and they're connected to the metal of the outside skin of the rest of the bus. Metal being such an excellent conductor of heat as it is, if this steel is in full contact with your stud, then your stud is picking up the thermal properties of this steel as well, and all of the heat that's in your living space will go through the wood, because wood does not have near the R value of insulation. Wood is about an R value of 1 per inch. And that little section of 1 per inch that's completely up against this steel will allow the cold inside your bus or the hot or the warm inside your bus or the warm on the outside of your bus, depending on the season, to very easily be conducted through your wall system to the outside world or to the inside world, depending on which way the heat's going. And that's really not ideal. Look at the way we do it when we go across this. So we have this, we'll call it our strap, which is essentially a stud, running lengthwise. And look at the contact patch here. I mean, it's only in contact with this very conductive steel for 2 inches, which is the width of it. The rest of the time, it's floating in space and it's got insulation behind it. So just by doing that, we've caused a much more effective thermal break to be created than by simply putting our 2x4s or plywood or whatever you're using directly into the hat channel. I did my first bus this way, and I had a laser thermometer and I could see on my walls where my frame was, because it was doing such a good job of conducting heat in and out of the bus when I didn't want to. If you'll remember in the last build video, I showed you how we make our wooden window frames to house our RV windows. Now that we've got the framing going on, you can see how those tie in. So we've got our 2 courses of our 3/4 inch by 2 inch wide plywood coming into the window frame. And then we're able to sink some trim head screws in this way to totally integrate it. And because it's attached to the frame here of the bus, this window frame is really going nowhere. And once we get our spray foam in these wall cavities, this entire window assembly will be locked in place. It's not going anywhere, and that's the reason why I feel so good not framing our windows in steel. The last bit of bus framing theory I want to talk about is how we handle the ceiling. The ceiling we do just like the walls, running our framing this way. Again, I've seen lots of folks do a bunch of little blocks on here so then they have a nailer to go into, and that's just creating another thermal bridge for you that's going to marry your wooden framing directly and completely to your metal framing and allow the very terrible thermal properties of the steel to really bring down the performance of your wood and the rest of your insulation package as a whole. So we never do it that way. What we do is we run our strapping lengthwise, just like we do on the walls. We do 2 layers. It minimizes the contact patch that's there, and that gives us the results we need. Now, if you want to save on ceiling height, you could do 2 courses of 1/2 inch. You could even do a single course of 3/4 inch, and where you have butt seams, put a splice and screw that in on top of, or well, behind it, I guess, but also on top of it. And that'll get you good results. If you are going to be insulating and trying to have your finished ceiling, the backside of it, flush with the steel, thus leaving your steel exposed, you're doing yourself a huge disservice, because by leaving, even if you fill this whole cavity with insulation, the best insulation in the world, spray foam, just by having this right behind the surface of your finished wall, it's going to bring down the performance of your ceiling insulation system significantly. I think you'd be very surprised if you go out there and read the building science journals. Just that alone could diminish the R value of your ceiling system by over 30%. Not a good idea, and it's a lot more work too. I want to take a minute and talk to you about spacing and what we really like to do in our builds. The first thing is we like to start with this row of strapping right on the floor. And I will show you how I do that, but what I like to do, instead of doing 2 layers back to back, all buses have a chair rail down there. If you do your 2 layers back to back, that chair rail is actually going to create another very good thermal bridge, and we don't want that. So I actually cut a layer, my first layer of the straps, just into blocks, and I space those blocks about every 16 inches and screw them in. And that's the first course on the very bottom. From there we go up 16 inches on center until we get to the top. When it's time to put in the top row of strap, what I like to do is go as high as I can until the curve of the ribs really starts to happen. And the best way to do that is to take a straight edge and just lay it across here, across your strapping that you've put in so far, and then slide a piece in and move it up and down until it's just touching your straight edge but not trying to push it out. That will be the last row of strap for your wall. One benefit to furring your walls out the 1.5 inches is that it actually starts to eat up a good chunk of the curve here, which leaves less curve for you to have to figure out how to trim out and deal with, and turns it a lot closer into a square roof and wall intersection. Moving up, we get back into our regular spacing, and then depending on how you are finishing your ceiling, I like to have either one right down the middle or two kind of close together in the middle. Sometimes people want to put like puck lights and stuff right down the middle. And if you do that, you want to make sure you don't have framing right behind there, or there won't be a wall cavity for your puck lights to recess into. Just a little thing to think about in advance. Now, I know some of you are probably thinking, if you run all of your strapping lengthwise, what if I want to do a ceiling made out of tongue and groove or whatever lengthwise as well? And a lot of folks like to do that. So say we've got our first course of strapping in this way. Well, then what you could actually do is kind of like weaving a basket, do your second course of strapping in sections between those ones. I hope that makes sense. So imagine you've got your straps running this way, and then say they're 16 inches on center. You could cut 16-inch pieces of your 3/4 and then attach those to the strapping running this way. And that's gonna give you the thermal break that you need by minimizing your contact patch with the steel framing. And then it's also gonna give you that arched style framing for you to shoot your tongue and groove or long boards into. We don't really do the long boards or the tongue and groove at my shop anymore. We've developed other ceiling systems that I think look just as good, and they let us stick to the simplified framing that's not quite as complicated and goes in a lot quicker. But again, it's up to you. The main goals are to minimize your contact patch with the steel, have a strong, wooden substructure for you to attach to that's not made out of dimensional lumber, so it's not going to split. And then to integrate that framing also in with all of your windows or whatever else is existing, so that you're finishing with as flat and true of a plane as possible for you to attach your finished surfaces to, or cabinets or whatever. This is how we frame that first row of strapping that I was talking about. We start with some blocks of our strapping material, and we go ahead and we're going to be screwing these to our chair rail. You got to leave the chair rails in place. They are structural. They're pretty important. And if you look, I've actually already spray foamed the gap between my plywood subfloor and the metal frame and the chair rail. Anyway, we'll be putting that down first with our self-tapping screws, and then on top of that, we'll be taking our full dimension piece and going over that. You see that gap there? That will get filled in with insulation, and that prevents the thermal bridge from being such an issue. I also want to highlight one reason why this is nice. If you look at this chair rail like in the corner, it actually kicks in a little bit. Never mind the confetti from the party we had in here. It kicks in a little bit, and that would be an issue, but what we'll do is we'll just put our last block a little ways in from that where the wall is still good, and we'll just float that out over it. So that way our wall stays true despite what's happening behind it here. Let's go ahead and get started doing this. This will be a good chance for me to show you now how well those self-tapping screws work, because the chair rail is actually thicker than the hat channel. So I was actually watching another channel, and the guy building a bus was talking about how buses are made out of high-strength steel. No, they're not. No, they're not. Maybe the frame rails. I know the Bluebird All-Americans use an extra high tensile strength steel for their frame rails, but not the TC2000s. Certainly not for the hat channels. These are just mild steel, nothing special. If you're having a hard time getting through it, it's not because the steel is extra hard, it's because your technique is poor. Whenever you're drilling through steel or metal in general, for the most part, speed isn't the answer. You want lots of pressure and a good appropriate speed so that you're clearing your chips, but not so fast that you're generating a lot of heat. So that's the first tip. Second tip is just to use the right fastener. So I've got this block here, haven't drilled through it. There's no pilots. We're just gonna take our Tex self-tapping wood to metal screw and drive home our first block on this row here, and you can see how fast it goes. You wanna make sure your head is fully countersunk into the block so the next layer sits flush. Just like that, one done, 20 to go. That was easy. So now that we've got our blocking in place for this first course of strapping on the floor, I went ahead and cut a piece to length. And what I'm gonna do is just go ahead and line this up, get ready and pilot drill all of my holes first, and then I'll come back in and shoot it down with screws. You want to make sure that you're not going to screw into your other screw. That's a sad day. Okay, all of our holes are pilot drilled. And now we'll just attach them with our number 8s. You can see our lovely countersunk screw heads, and they're all countersunk nice and flush. And we've got the gap behind here for our spray foam. And in this corner now you can see there's an extra piece of steel, and since I'm able to kind of float this out, that's not a problem. It's not going to cause our framing to kick in. Framing for the rest of the wall will be very similar, except we will be using a solid piece of 3/4 inch plywood instead of blocking. One important thing to note is that whenever you have a seam like this, you want to stagger your seams and make sure you get fasteners on both sides so that you end up with something very rigid. A pro tip for when you start getting your layout for the ceiling is to go ahead and snap a chalk line for dead center. Find your center point in the back of the bus, center point in the front, and snap a line. Then as you frame out, measure out from that center point so that your fastener spacing, if it's visible, remains even throughout your entire ceiling. Keep in mind though, no bus is totally square, and as things progress, you may have to cheat things left or right. I recommend always pulling a tape as you work your way forward or backward on the ceiling, framing out the bus, to make sure that you're not building yourself into a corner where one side's gonna be lopsided compared to the other simply because your bus came that way from the factory. If you're like me, you'll be attacking this framing job by yourself, and that means there are going to be plenty of times when you wish you had a helping hand. That's when a thing like this spring clamp, or any clamp really, comes in handy. Say you're laying in a long piece of strapping across these ribs. Say it's 8 feet long because that's how they come. What I like to do is take this clamp it on the hat channel, right even with the line of where I want the bottom, and that will hold up that end of the strap while I go down to the other end of it and start attaching it. It's a way to move really quick, and it works on the walls just as well as it works on the ceiling. You can stick your piece of wood in the mouth there and let it pinch that. You'll be off to the races. This is a very useful tool, indispensable if you're doing it yourself. Well, I think that's going to do it for this how-to on how to frame the exterior walls of your school bus. I hope you found these tips and tricks useful. I can guarantee that they're going to save you time and energy if you were considering doing it a different way, and they might even give you a wall system that performs better in any climate you may travel to. In the coming videos, I'm going to be detailing how we get prepped for spray foam, how we get spray foam, and then after the spray foam, how we frame our interior walls. So don't go anywhere. Make sure you hit that subscribe button. My name's Chuck Cassidy. Thanks for being here, and we'll see you next week.